Okay, folks, now what we want to do is we want to talk about Heron's formula. This is a formula about finding the area of a triangle without knowing any angles. It's actually a very old formula. Heron lived about 2,000 years ago, but it's also a very interesting and powerful formula. So let's introduce this by showing you a triangle. Okay, we have a triangle, and it's a dynamic triangle. We can move things around. Okay, notice we have triangle A, B, C. Here's side A, side B, and side C. Okay. Also notice if you look around here, I have all of the angle measure, not the angle measures, but the side measures. Okay, and we could change B as well. All right, so all of those are changing. And also in addition, we have the height. Okay, the height of the triangle. So again, I'm just going to, demonstrate the height. We could get that really low. We can get that really high. Okay, all of these values are measured accurately. All right. Now, if you would notice, I have a representation of the area of the triangle. We all know that the area is equal to 1/2 the base times the height. Okay, in this case, I have it calculated 81.65. So let's see if that makes sense here. Okay, if I move this down, the area should be getting very, very small. Okay, very, very small. Also, if I changed B to a number that maybe we can all relate to, like 16. Okay, here's a number close to 16, and then I move the height down to a number. Oh, let's say here I have 10, right? Close to 10. So 10 times 16 is 160. Half of that is 80, and lo and behold, down here the area is 80. Okay, so this does work. Okay. Also, notice my triangle. I could move it all the way this way. I can make it an obtuse triangle, and I still have the height being shown here. And we know that from our previous learning demonstrates the correct application of the formula for the area of a triangle. Okay, now what I did is I added a couple other things. So this expression right here is the half the sum of the sides of the triangle. So again, I have all of the sides of the triangle. I have A, I have B, I have C, and I'm going to add them all up and divide by 2. Okay, so that's what this expression is at the bottom. Now I am going to call that expression S, my special number S. And so I'm going to use S in this formula, also known as Heron's formula. Now what is Heron's formula about? Heron's formula says that if you compute S and then you apply S in the formula, which is what? The square root of 4 things. 4 things. So first of all, it's S. Then it's S minus A, which is the length of S minus the length of A, right? Okay, so I have S minus A, S minus B, S minus C, okay? Now I asked the software program, Geometry Sketchpad, to compute that for me, okay? So here's that number, 83.90. Now the question is, are these two formulas the same? Well, if I move my triangle around, okay, notice I have these two, this area and this area. Again, the question is, are they the same? Okay, and the answer to that question is yes, they are the same. So this verifies numerically Heron's formula is an accurate way to be able to find the area of a triangle and not knowing the height and not knowing any angles. I think that's really very, very credible and very applicable, especially in the field of surveying and area of land. That could be a very helpful tool to use to figure out accurate numbers. I hope you enjoyed learning a little bit about Heron's formula.